Welcome students. In this video lecture, we are going to study about the classification of solids. Crystalline solids, amorphous solids and polymeric solids. Solids are materials characterized by structural rigidity and resistance to change in shape and volume. The molecules in solids are closely packed and organized in different ways, which gives rise to varying physical and chemical properties. Solids can be broadly classified into three categories: crystalline solids, amorphous solids, and polymeric solids, as shown on the screen. Now, let's discuss these solids one by one. First, we have crystalline solids. Crystalline solids are most commonly known type of solids. They have a highly ordered arrangement of atoms or molecules, which extends over a long range. This arrangement is periodic and repeat in all three dimensions, forming a crystal lattice. Characteristics of crystalline solids. First characteristic we have is regular arrangement of molecules. The atom ions or molecules in crystalline solids are arranged in a specific repetitive pattern, ordered structure. Crystalline solids exhibit an organized and well-ordered structure due to the periodic arrangement of their particles. Third characteristic is sharp melting point. These solids possess a distinct melting point, meaning they undergo a sharp phase transition from solids to liquids at a specific temperature. Fourth property we have is amplitude increase with temperature. As the temperature increases, the amplitude of atomic vibration in a crystal lattice increases, eventually causing these solids to melt at its melting point. Common examples of crystalline solids include metals such as copper and zinc, as well as ionic compounds like sodium chloride. Now, let's discuss the second type of solids, which are amorphous solids. Amorphous solids differ from crystalline solids in that they lack a long-range ordered structure. The molecules in these solids are arranged more randomly, similar to liquids, but without the ability to flow freely. Now, the characteristics of amorphous solids. First characteristic we have is no regular arrangement of molecules. Unlike crystalline solids, amorphous solids do not have a regular periodic arrangement of their molecules. Glass is a common example of an amorphous solid, as shown on the screen. The second characteristic we have is gradual softening. Amorphous solids do not have a sharp melting point. Instead, they soften gradually over a range of temperatures. Glass, for instance, softens gradually when heated at around 800 degrees Celsius. The third characteristic we have is no definite melting point. These solids do not have a distinct melting point or melting temperature, meaning they transition into liquid phase more gradually without a sharp boundary. Fourth characteristic we have is glassy solids. Amorphous solids are often referred to as a glassy solids due to their presence and behavior. Examples include glass, plastic, and certain type of rubbers. The third type of solids we have are polymeric solids. Polymeric solids are materials composed of large molecular chains or polymers. They can have properties of both crystalline and amorphous solids due to their intermediate structural arrangement. Now, it's time to discuss the characteristics of polymeric solids. First characteristic we have is intermediate structure between regular or irregular. Polymeric solids exhibit structures that are not highly ordered as crystalline solids. but are also not as disordered as amorphous solids. Their molecules are typically arranged in a long chain with varying degree of regularities. The next characteristic we have is massive long chain molecules. These solids are characterized by the presence of long chain molecules that can be repetitive units of simpler molecules. This gives polymeric materials their distinctive properties such as elasticity, flexibility, and toughness. The next characteristic we have is plastic and rubbers. Many plastics and rubbers are examples of polymeric solids. These materials are used widely in everyday life due to their versatility, flexibility, and resistance to chemicals and wear. This is the chart of comparison of crystalline, amorphous, and polymeric solids. It's important for you to remember all these properties of crystalline solids, amorphous solids, and polymeric solids because they are important for entry test preparation. The classification of solids into crystalline, amorphous, and polymeric categories highlight the diverse behavior and properties exhibited by these materials. Crystalline solids are characterized by their ordered structure and sharp melting points, while amorphous solids are more disordered and lack a definite melting point. Polymeric solids, with their long chain molecules, often exhibit a combination of characteristics from both crystalline and amorphous solids, depending on the nature of the polymer. Understanding these classifications allow us to predict the behavior of materials in various industrial and everyday applications. That's all for this lecture.